Hello everyone, welcome to this video. This video is on architecture of 8051 microcontroller. So let us see which are the registers, ports and few features of microcontroller 8051. In the last video, we have seen the block diagram of 8051. Here the components are discussed: interrupt control, CPU, oscillator, bus control, ports, serial port, RAM and ROM. These are the main blocks of 8051 microcontroller we have seen in the last video. Now let us see the architecture of 8051, that is giving more details. So these are the features. So there will be 8-bit CPU in the architecture with register A and B, and we have a program counter PC and data pointer DPTR and a 8-bit program status word register and a 8-bit stack pointer register and a 4K memory, that is ROM, code memory or program memory, 128 bytes of RAM, random access memory, 32 IOs we have, that is arranged as 4 ports, and each port will be having 8 bits or 8 pins. Two 16-bit timer or counters will be there, T0 and T1. There is a UART port, that is full duplex communication. It will support serial communication. There are some control registers: TCON, TMOD, SCON, PCON, IP and IE. 2 external interrupts and also 3 internal interrupts are there. So these we need to find out in the architecture now. This is the complete architecture of 8051 microcontroller. Here you can find this is the CPU. This CPU consisting of ALU. This ALU will take only 8-bit of data from the temporary registers. So these temporary registers are there to provide the data to ALU. Before ALU do the processing, it will take the data from the temporary registers. You can see above the temporary register there will be register A and register B. This register A will be called as accumulator. So why it is called as accumulator means whatever the function done by ALU, that output will be come and stored in this accumulator. Means the output will be come and accumulate over here. That's why it is named as register A. This register A also stores 8-bit of data, and whenever the ALU requires the data, it may use register A and take the data from there to temporary register also. This B register is also a 8-bit register. So A and B are the registers that will help ALU. And then we will be having PSW. This is program status word register. So what is program status word means? It is also a 8-bit register. It will be having 8-bit of information. 8-bit of information, we call it as flags. So this is indication of whether ALU output is 0 or it is producing a carry, or the output is not 0 or it is producing an auxiliary carry, like that. It is giving a flag information, the status of the microcontroller. That's why it is called as program status word. In the next lecture, let us see what is program status word, which are the bit places corresponds to the particular flags. Now comes the RAM address register. This is corresponds to the random access memory what we have. We have seen here we will be having 128 bytes of RAM. This RAM is for data communication. So the RAM address register will be having the address of the data locations which is stored in this 128 bytes of RAM memory. And we have a timer and control unit. There will be 2 timers as we seen in the previous block diagram, timer 0 and timer 1, that can also be worked as counters. So timer and control unit will take care of that timers. And we will be having instruction register also. And then coming to the stack pointer, you can see here there is a stack pointer. This stack pointer is going to point, suppose this is a memory, we are going to use push and pop instructions to send and retrieve the memory from the stack memory. Push will be pushing the data into the stack. This is a kind of memory. Pop will be pop out the data from the stack. So these are the 2 instructions we are going to use. So for this we require which address the pointer is locating at. So which address we will be having now. So that current address will be held by the stack pointer. This is stack pointer. It will be holding the address of the stack memory. And then we'll be having a program counter and program incrementer. This program counter will be having the next address which is going to be executed, means the next instruction address which is going to be executed. This is pointing to the next instruction we say, and this program counter incrementer to automatically increment to the next address once that instruction is executed. And then we will be having DPTR. This is also a 16-bit, this is also a 16-bit register. DPTR is data pointer. This data pointer will be pointing to the external data memory, where this can be pointing to the memory location of the data which is present and we are using as a external memory. And there is a program address register with respect to ROM also. You have seen here RAM address register. This will be holding the address of the RAM locations. This will be having a data, and ROM will be having a program, or we are going to use this to store the instructions. So this instruction memory ROM will also be having a address register. So this will support ROM. This RAM address register support RAM. And there are some special purpose registers also, as I said, TCON, SCON, PCON. So these are the special purpose registers. They are going to be used in serial communication and interrupt control in those cases. And you can see here there are 4 ports: port 0, port 1, port 2, port 3. This port 0 will be having pins from 0 to 7, means totally 8 pins are there. Here also there are 8 pins. Here also there are 8 pins. Here also there are 8 pins. Totally we will be having 32-bit IO pins, or 32 IO pins, 32 1-bit IO pins present in this 8051 microcontroller. So these 32 bits are going to be arranged as 8-bit, 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 8-bit pins. So particularly port 0 will be used for some purpose, port 1 will be used for some purpose, port 2 will be used for some purpose, or port 3 will be used for some particular purpose. And you can see here there are interrupt timer, serial port, and memory control ports also there. So this is the complete architecture of 8051. So you can see there is a latch and also the buffer. This latch will be holding the data before we are going to send that to port out. Buffer is the one which will keep the data which is coming inside. So you can see here from the buffer it is coming data into the memory, into the microcontroller. Latch will be supporting for the data which is going out from the ports. So this is about the architecture. Quickly you can see here PC is the program counter, will be having 16-bit register, hold the program memory address of the instruction being currently fetched, that is program counter. DPTR is the data pointer register. This is also 16-bit, hold the external data memory address of the data being currently fetched. And ALU is an arithmetic logic unit used for arithmetic and logical operations, and it gives the result. And A is accumulator, 8-bit register, B is B register, 8-bit register. And PSW is a program status word register. It will be having different flags in each and every bits. And then we have ports P0, P2, P1, P3. So this P0, an 8-bit port for IOs in a single chip mode, or for data bus come lower order address in the expanded mode. P2, this is also a 8-bit port. It is IOs in the single chip mode, and for higher order address in the expandable mode. It means the lower order address means the total address will be 16 bits. Out of those 16 bits, these are lower 8 bits of address will be given or will be supported by P0. And the higher address, these 8 bits will be provided through P2. That is what the meaning of higher order address and the lower order address. And P1 is an 8-bit port for IOs in single chip mode and few device operations related to 8051 family variations in the expanded mode, that is P1. P3 is also act as IOs, 8-bit ports are IOs in a single chip mode, and serial interface, timer, T0, T1 inputs, interrupts, inputs, RD means read, write for the memory read write operations in the expanded mode. So these ports can be used as IOs all the time. That will be called as single chip mode. Whenever we are going to use those pins as IOs, we call it as single chip mode. If you want to use the port for serial interface like UART communication for transmission and reception. We are going to use port 3.0 and port 3.1 pin, 2 pins. In such cases, we call it as expanded mode of operation. Where suppose if we want to treat those ports as P3, other ports as INT0 and INT1 inputs, then we say it is in expanded mode. Like that, we are going to use the ports. And then we have SI, that is a serial interface, full duplex, UART, serial input output operations through set of 2 pins of P3. I said P3 is used for the serial interface. RXD and TXD are the 2 pins we are going to use. For half duplex synchronous communication of the bits through the same pins as data and clock. And T0 and T1 are the timers we are going to use. It is going to use 4 registers extra, TH1, TH0, TL1 and TL0. These 4 registers corresponds to these 2 timers, T0 and T1 timers. And we have special function registers, as I said, stack pointer, program status word, register A, that is accumulator, B, IE, IP instruction pointer, interrupt enable, serial communication port, TCON, timer control, serial communication control. So these are the different special function registers we will be having. We call it as SFRs. These all other registers will be called as special function registers. And we seen ROM, that is EPROM, means electrically programmable ROM, means microcontroller we can program from the external world. So in such cases we are going to use the ROM. In ROM we are going to load the instructions or the program. So it is electrically programmable ROM. You can program this electrically. That's why the name is EPROM. Or it will be flash EEPROM, electrically erasable and programmable ROM of 4 KB. And then we'll be having an internal RAM, that is random access memory for read and write operations. 128 byte of memory is indirectly or and directly addressable in address space. Let us see direct addressing and indirect addressing in the memory discussion. And then we'll be having register banks. There are 4 set of register banks. We have 4 register bank. Each will be having each of 8 registers, and those are also part of internal RAM. So the internal RAM will be divided into 4 register banks. So this is about the architecture. If you look at the pin diagram, this 8051 microcontroller will be having total 40 pins. These 40 pins will be divided as P1, P2, P3 and P4, and other pins, these are 8-bit pins. 8 into 4, that is 32. So other 8 pins are, you can see, this is VCC, VPP, ALE, address latch enable, PSEN, and this is for these 2 for oscillator and ground reset pin. Apart from that, P1, P3, P0 and P2. So this P1 can be used as IOs, and in expanded mode it is used for special purpose. If you see P0, you can see the first pin is P0.0 is the 39 pin, that is address 0, address 1, address 2, address 3, 4, 5, 6, 7, means 8-bit address we can use, we can give from here. And the higher order address 8, 9, 10, 11, 12, 13, 14, 15 can be given here, 8-bit address. Next, it is lower order address, it is upper order address. Totally it becomes this 8 and this 8 becomes 16 bits. This is how the pin diagram of 8051 microcontroller look like. Here in P3 you can see RXD, TXD, interrupt 0, interrupt 1, timer and write read pins also present. This is about the architecture and pin diagram of 8051 microcontroller. Let us see more details on this in the next video. Thank you.